Okay, so in this video, I just want to talk to you about the other parts of the square of opposition. Again, these are parts that won't be used in our class, but I want to at least give you some sense as to why a relationship between an A statement and an E statement isn't guaranteed, okay? So it might be helpful for you to be looking at the square of opposition itself while I talk you through these examples. So let's say our A statement is all cats are mammals. Then the corresponding E statement, right, would be no cats are mammals. That would keep the subject and predicate terms the same, as we were talking in the previous video. So in this case, right, the first claim is true, as I say here, and the second claim is false. You might think, okay, yeah, right, all and no, they should have opposite truth values. Why aren't they contradictory? Well, we can see that in the second example here, right? So in the second example, let's have our subject be unicorns and our predicate term be mammals, right? So all unicorns are mammals. So remember what all means. It means if there was such a thing as a unicorn, it would be a mammal. And that is true, right? Because a unicorn is essentially a horse with a horn. A horse, you know, it has live, a young, it has hair and so forth. So a unicorn then would be a mammal. That is true. But at the same time, right, to say no unicorns are mammals is also true, right? Because there is no such thing that is both a unicorn and a mammal, all right? So the point here being, sometimes between A and E statements, one's true and the other's false. Sometimes, though, between an A and an E statement, one's true and the other is also true, right? And other examples could be generated for the other possibilities here. But the thing I'm just trying to emphasize in these examples is, as I already said, there's no guaranteed relationship between an A statement and an E statement. All right. The same thing can be seen with regard to I and O statements here. So let's take an I statement, some cats are mammals, right? And that, of course, is true. Let's remember that, because some means there is at least one thing that is a cat that is also a mammal. We know that every single cat is a mammal, but it is true that at least one cat is a mammal. And then compare that with the next claim, some cats are not mammals. That's the corresponding O statement. Some cats are not mammals is false, right? There is no, you cannot find even one cat that is not a mammal. So that is false. So that sort of meets our expectations, I think. However, when we change the content here, so in these second examples, we have some cats are tabbies, and that is true, right? At least one cat is a tabby. But it is also true that some cats are not tabbies. There's at least one cat that is something other than a tabby. And so once again, just trying to emphasize that between the I and the O statement and really any of those relationships around the outside of the square of opposition here, there is no guaranteed relationship. If you know one of the claims is true, you won't know if the other one is true or false, except when we're dealing with the contradictory relationships, again, between A and O and I and E, okay? So we just want to, understand how the square of opposition works and know that we're only going to be relying on the A and the O relationship and the I and the E relationship.